Today we will learn how to find the derivative of a multiplication of two functions. When we have two functions u and v, then the derivative of the product of these two functions can be found as u multiplied by the derivative of v with respect to x plus v multiplied by the derivative of u with respect to x. This is known as the product rule in differentiation. So for example, if you are given a question y equals sine 2x multiplied by cos 3x, we can use the product rule to solve this question. So here we can consider sine 2x as u and cos 3x as v. So the derivative of y with respect to x will be equal to u multiplied by the derivative of v, that is sine 2x multiplied by the derivative of cos 3x with respect to x, that is minus 3 multiplied by sine 3x plus v multiplied by the derivative of u with respect to x, that is cos 3x multiplied by the derivative of sine 2x, that is 2 into cos 2x. So finally we get our answer as minus 3 multiplied by sine 2x multiplied by sine 3x plus 2 multiplied by cos 2x multiplied by cos 3x. So this is our final answer. So now let's look into the proof of this theorem. Here we let u equals a function f of x and v equals another function g of x. If we consider their increments, we can write u plus delta u is equal to f of x plus delta x, and v plus delta v is equal to g of x plus delta x. Then we take another function y which is equal to the multiplication of these two functions, that is u multiplied by v. So here we can substitute u and v with f of x and g of x. So y will be equal to f of x multiplied by g of x. So this will be our first equation. Like in our previous video, we can write our second equation as y plus delta y is equal to f of x plus delta x multiplied by g of x plus delta x. Here we need to mention that delta x is an increment of x and delta y is an increment of y corresponding to delta x. Then we can subtract equation 1 from equation 2. So this will give us delta y is equal to f of x plus delta x multiplied by g of x plus delta x minus f of x multiplied by g of x. So then what we do is we substitute this with this u and v. So instead of f of x plus delta x, we can write u plus delta u. And instead of g of x plus delta x, we can write v plus delta v. And instead of f of x, we can write u. And instead of g of x, we can write v. So this gives us u plus delta u multiplied by v plus delta v minus u multiplied by v. So then we can open these brackets. When we open these brackets, we get delta y is equal to u multiplied by v plus u multiplied by delta v plus v multiplied by delta u plus delta u multiplied by delta v minus u multiplied by v. So here this uv and this uv will cancel off. Then we divide both sides by delta x. So delta y divided by delta x will give us u into delta v over delta x plus v into delta u over delta x plus delta u into delta v over delta x. There is a reason why I brought this delta x under delta v here and here under delta u and here under delta v. You will see why when you look at our final answer. So here we need to understand that as delta x tends to 0, delta u will also tend to 0, delta v will also tend to 0, and delta y will also tend to 0, because we have mentioned here that u is a function of x and v is also a function of x. So as delta x tends to 0, these will all also tend to 0. So then we apply the limits. So limit of delta y divided by delta x as delta x tends to 0 will be equal to u multiplied by limit of delta v divided by delta x as delta x tends to 0. Here, because u is a constant here, plus v multiplied by limit of delta u divided by delta x as delta x tends to 0. Here v acts as a constant, and here delta u multiplied by limit of delta v divided by delta x as delta x tends to 0. So here we see that as delta x tends to 0, delta u will also tend to 0. So this whole thing will be equal to 0. So here this part will be equal to dy by dx, and this part limit of delta v divided by delta x as delta x tends to 0 will be dv by dx, similar to this part. Here this is dy by dx, so this part is dv by dx, plus v multiplied by this whole part will be du by dx. So this is our final answer. Just like that, we have proved the product rule. So this is why I took delta x under delta v here, and here delta x under delta u, so that we can get our final answer according to our product rule. There are plenty of exercises in the description below for you to attempt. The answers are also given for your reference. So until we meet again, take care.